them in the chat, and I will go ahead and ask them of Steve, and he'll answer them away. And with that, Steve, thank you very much for coming today. It's all yours.
Well, thanks. So you might be wondering, why are we talking about artifacts at a container plumbing day? Well, it turns out containers don't just run themselves. They're supported by other artifacts. So where are you going to store those production critical assets? Hi, I'm Steve Lasker. I'm a PM architect for Azure Registries. I focus on our end-to-end container workflows because registries kind of sit in the middle of all of these container environments. I also spend a lot of my time in the community because it's great working with other folks and we get a lot of input, but it's also support the Microsoft business. Microsoft isn't just a cloud, we're a software company. And we need a way to distribute our software from MCR, the place where we distribute our container images, to other cloud and local registries. So this work that we're talking about here is done intentionally in the community because we want all registries to be able to support it. And what we'll talk about here is the evolution from what we did with the initial artifact approach to now supporting reference types. So first of all, what exactly is an OCI artifact and why is it that you care? Well, you probably are realizing that there's other assets that you need. And you're wondering, like, where am I going to store those? I already have this registry as a production critical asset. It's fed by dev input, but it's sitting there, hopefully, right next to your compute, not in another region across the internet, but you have a local copy of the content in your own private registry. It's secured with your authentication. It might be in your own VNet. You might be doing security scanning. You have your own access to audit logs. You might be doing double encryption at rest. There's all kinds of capabilities that you can do on those container images. Well, why wouldn't I use that same infrastructure for the other artifacts that I need, right? Same permission boundaries you can set up, the same security, same networking, and so forth. And registries are ubiquitous. You're here at a container day. Obviously, container registries are part of that end-to-end experience. So wherever you go, every cloud, on-prem, there's always a registry available for you. Now, when we talk about artifacts, we think about, like, well, am I going to build yet another storage solution for that particular artifact type? Do I need to run a Helm chart, repository for Helm charts? Well, you can put them in a registry. You don't need to run that. You don't need to run a WASM server or even any of these other artifact types. In fact, you might be trying to build a new artifact type and you don't want to take the burden of trying to build yet another storage solution because there's typically a REST endpoint to interact with. There's some kind of blob storage. There's some kind of authentication. You probably have some kind of caching. And then who's going to support this thing? Well, we had that same question in Azure when we started exploring supporting Helm charts, and then it was Singularity, and then it was CNAB, and then it was, the list goes on and on. We said, all right, rather than chase every one of them, what if we generalized registries to support all these artifact types? And then we can get the benefit of all the features that are already on those registries, and we just say, pile more content in. Just like your local disk on your computer can store all kinds of file types, we want registries to be able to do the same thing. So if we look at container registries today, or yesterday, prior to artifact approach, you can store an image, and that's fine. But what about these other things? And the list goes on, right? The success of any large volume business is you don't know all of your customers. I have lost track of all the different artifact types that get stored in registries. Registries. They just made the content look like a container image. This is the same hack we used to do when we try to send email attachments, and the email scanner would say, nope, you can't send that binary. So the first thing we did, change the extension to .txt, or put it in a zip file, or just name it .zip. We didn't even necessarily zip it up. And the email server said, yeah, that's fine. So it turns out people are already storing in it. How do we kind of level that up? And enable registries to store other artifact types so I don't have to build yet another storage solution or a YAS. So this was the change. The change is fairly minimal. We'll go into the details of it, but basically registries now can store all different artifact types, including container images. Now, the original focus was on the things that don't have a solution, right? We kind of weren't looking to solve, it ain't broke, don't fix it kind of thing. And as we started doing this, we started hearing more and more feedback that this is great, but what about these other packages that I'm already using that I don't have good private instance versions of it? I don't have all the IDs, I don't have the security, this reliability, the availability, the performance ability that I have with container registries on other things, even the production public ones like NPM and NuGet and stuff. So what we've actually done is taken this even further and saying our container registry infrastructure with all of those capabilities can support other package managers as well. So now you can get a unified interface for how you're going to set up auth and VNets and security and replication and availability zones and so forth on all of these package types. But let's take a step back and look at how this kind of can work together. Not just images, but all artifacts are stored in registries. So on the right, I have a registry. It's got a REST endpoint for discoverability, and then it's got a blob endpoint for how it delivers content. And a registry basically stores two different content types: a manifest, it's a JSON schema that describes the thing, and the actual content. And the rest is just noise that supports that information, including a tag mapping. So if we look at a traditional Docker flow, the Docker client says, hey, I want this thing. Hey, registry, can I have this thing? Can you tell me what it needs to get this thing? And the registry says, oh, here's a manifest that describes the thing. And the thing is made up of some content that we'll go into a manifest in a second, but it's basically, here's some blobs and a config object that's available. They all have unique IDs because we can leverage this caching model that I might already have some of those blobs locally. And in this case, in the first ephemeral client boot up, it says, well, I actually don't have anything. So the delta is actually all of the content, all of the layers. So it says, hey, server, can I have these layer IDs, the blob URLs, so the client can now go fetch them. And then the client goes and fetches those at 2 or 3 or 4 at a time, right? You can run multiple threads and bring that content down, decompress it, and so forth. And then once those layers are available, the image is available, and the client can then start running. It turns out this handshake that can work for multi-gigabyte images, right? We always think the images should be small, a couple hundred meg. Yeah, we all know that there's very large multi-gigabyte images. So we know registries scale to this upper end. And of course, they can scale down to very small 100K single layer images. But how does this persist it? I mentioned this manifest. And there's lots of manifests in the world, but this is an image manifest for persisting things in a registry. And the distribution spec states that I must support at least 2 manifests. One that describes the image, the container image itself, which is what I'm looking at here. And there's this media type that says this is an image manifest. And then the content that's within it is described as what's called an OCI descriptor. It's basically a digest that says what this thing is, so I can tell the difference between a config object and a layer, or other things, as we'll see. But it also then takes the content and creates a digest from it, a SHA-256 digest of the content as a whole, and that becomes the unique ID of it. And then there's a size as a checksum there as well. So what you're seeing is there's 3 different blobs that we're storing, and we have a content descriptor to get access to them. The specific content is there's this config object that could have everything from platform to startup environment information, whatever it is that you think is a configuration for this instance. And then there's the actual content as layers. And it's just in the container image, it's layers because there's an ordinal file system that overlays. Now, an index is nothing more than, well, first, it's the other manifest type that registries must support. And then all it does is it stores a collection of those images that we just talked about, differentiated by platform. So this is what gives us the ability to say, I want the Hello World image for Windows or Linux or ARM or what have you. And you as the author can publish that, and then your clients can just pull that by Hello World latest, Hello World v1, whatever. And as long as there's a multi-arc index, the client can negotiate with the index, figure out which one it should pull, and then it goes and pulls that manifest that we have here on the left. So that's the standard flow. The interesting thing about the index is it is a single document that has the entire collection in it. So if I want to, in fact, when I build this up, if I add, because this is ordered, it says Linux first and then Windows. If I add Windows, I have to update this index. If I want to add ARM, I have to update the index. And there's really no correlation between those in the index. It just says here's a collection of things that make up this tag. So this works reasonably well for multi-arc. Some would debate that. But there's really not a relation to each other. It's just saying this is a collection of things that make this up. Now, the next part is how do you define what that artifact type? If we don't want them to all look like container images, how do you differentiate those? And why is it important to differentiate? Well, you want your security scanner to know that the content that is actually a VM or a Helm chart, that when it tries to scan it and it fails, it shouldn't have even tried to scan it. Or in this case, the Docker client, if I'm not paying close attention to that full URL, that URL might look like it's the WordPress image. But if I look a little closer, we'll see actually this was the WordPress chart. So the Docker client can't run the chart. The Helm client needs to run the Helm chart. And then the Helm client or the Helm environment will actually go and pull the images because the chart will reference images and so forth. So it's important that it's not just for visual candy, but we want the CLIs to actually know what is the type that they're working with as well. So, how do I know the difference? Well, we went through this early on, and we decided that we're going to use the config media type to define what actually makes one artifact versus another. In this case, this is an image. We see it's an image config, and you can see the other media types that we use for other artifact types as well. So here's just an example. So basically, that config.media type will be placed with that string on the right for each one of those. And you can create whatever one you want. You don't need to check with the OCI org. You just register it with IANA. You make sure that that is the clearinghouse for the unique type, and you're good to go. So if I wanted to visualize this, I can see that, they're in a portal. I could say that this is the WordPress. That's just a string. How do I know what it is? We can put an icon on it. Here's some visual candy. And we know this because it is the config media type. So that's how all this gets stitched together. And that's how the Docker client can know, hey, should I even pull this thing with a Helm chart or CNAB or whatever you. So then the question is, why config? It's kind of weird. It's kind of stuffed in it. Well, we agreed. We tried adding a new artifact type property to the image manifest. We wanted to try to say, no, this is now an artifact manifest, and images are just one of the many things that use this. And this turned out to be more problematic. You could argue we didn't have good versioning in a lot of the client tooling for images. Regardless, it was considered to be enough of a problem that we decided that we could still do. That's how we actually came to this. Like, what if we just use the config.media type? So that's how we settled on what we call artifacts v1. And the config doesn't actually need to have an object. It's just, the media type is there, and the object itself could be null if we need it. So we basically had, all right, well, this really isn't an artifact manifest. It's still an image manifest that we're kind of using this media type to pivot on a bit. And that was good enough for a while. But now we're starting to think about the next evolution of things that we want to store in a registry. Now we've got container images. We've got WordPress charts. Sorry, Helm charts of the WordPress. And these themselves define their content. They have the netmonitor image. They have the blobs that represent the image. The Helm chart has blobs that represent the chart. The OPA policy manager, same thing. Now, what we have here is there's no anything interacting with each one of these. They're all individual artifacts in the registry.
Steve, I think we had a question on the last slide, which is,
sure.
Why is config an IANA media type?
Why is that? So how do we figure out, as registries, if we want to be able to define uniqueness, and we kind of learned this from some of the file systems, including the Windows file system clearinghouse. Where is the clearinghouse for it says that who owns that type. If we as ACR, GCR, ECR, whoever, IBM Registries, want to represent the icons or differentiate it for different clients, how do you claim a unique string? So we already have a registration org with IANA, so we just leverage that. It's a pretty straightforward process, and that was the only reason. We didn't want to reinvent another clearinghouse. Make sense? All right, well, I guess it's not really a conversation, so I'll look for other questions. Okay, so host different, okay. I'll come back to that. So now the thing is, I can store these individual things in a registry, and that's good. But how do I sign them? How do I add an SBOM? How do I add yet another artifact type that wants to enhance that artifact that's already there? Now, I kind of talked a little bit about immutability and the changing of the index and so forth. One of the things that makes registry scale so amazingly well is that the majority of content, other than tags, everything is immutable. I can push content to a registry, I can geo-replicate it, multi-master. I don't have to worry about conflict resolution. And my deployment script, if I want to reference it by tag or by digest, I don't have to change that. I don't want to have to change that just because I add a signature associated with it, or an SBOM, or anything else that's associated with that. I want to enhance that artifact without having to change it. So this has been one of the things that, okay, that is a requirement. How do we support that requirement?
We have another question asking, are you aware of anybody trying to use OCI artifacts to host other container image formats? From Silvano.
Yes, define a container image format, but yes, you could argue Singularity is a different format. They were one of the initial ones that we built the artifact approach around. There's confidential computing work that's going on. I'm trying to think, Nidus is another way of doing an expansion format, similar to the same concept as what we're doing with Teleport and ACR. So yeah, you can basically store anything you want. In fact, again, we've lost track of all the different types. Tools you could use it. Okay, I think that's covered. So then the question is, do I have a list somewhere? So as I mentioned, like we started keeping track of this, and then we realized that that's like trying to keep track of all the file types that can be stored on your local disk. The definition of success is we created an API, we created an environment that says that we don't have to know all the types. Fortunately, one side is we don't have a list. There is a PR that people can make for what types that they can support, but we haven't been able to. We haven't seen people do that. They just kind of run with their own types. Okay, so now, sorry, we go back one more slide. So what we're basically saying is it's great. We have all these individual things that we can store in a registry, but how do I associate them? I want the notary signature of the net monitor image. I don't really need the net notary signature by itself. It doesn't have any value unto itself. It's really signing the net monitor image. The SBOM is for the net monitor image, so on and so forth. And if I were to look in a registry listing, maybe I can look at tags, maybe I can look at manifests, but what would that look like? Do I just have all these things, the tags named as something, and there's some naming by convention, and I could digest? And I know there's certain things that have done this because it's what works today, but it's kind of pretty bad experience, right? It's really kind of leaking the internal details out to the user. And we want to be able to associate, some affinity to what that thing is. But here I just wind up with this big flat list that at best is, ordered in some way, and we know this will never be reality. What we really want to be able to say is, while there's individual artifact types from images to Helm charts and other things, that there's other artifacts that extend the artifact that's already there. In this case, a signature on a container image, an SBOM for a container image, some metadata associated with the container image. So that's the kind of model, not just for visual eye candy, but for an API to know that as well. So if I go back to this graph of individual objects, and if you notice here, there's a collection of signatures. Each one of those are individual artifacts that are for different signatures. That what we want to be able to do is say, look, let's take the net monitor image And if we look closely, the image itself, the manifest that makes up the net monitor image, references the config object, the layer, and another layer. There's a manifest that has the descriptors that says this is the content. This is what makes up this thing.
I have another question for you now. Would you see Creo snapshots being useful stored as reference type on container images?
I'll leave that to the Creo team to decide that, and possibly. So let's go through this a little bit more, and we'll see. So, because I want to get through some of the details, then maybe that'll pop up some of the answers to some of these. So if I have the Wabbit network signature, which itself has a blob and config, maybe, but it's got its own content, how does it say it is associated with the net monitor image? Notice the arrows are going the opposite direction. This net monitor image only knows about its content. The Wabbit network signature not only knows about its content, but it says it's enhancing this other artifact. So how would we do that with an SBOM, which also has a signature? There's this YAT, maybe it's a Creo, whatever. There's a YAT that enhances the SBOM. It doesn't even enhance the signature. Sorry, the image. It enhances the SBOM, which, by the way, it's also signed. So you're starting to see this graph of things that you can create and track in a registry. So how would we do this? This might be go to some of your answers. So the distribution spec says you have to support at least 2 manifest types. What we're saying is, let's say if it's at least 2, then there could be a third. So here we're introducing a new manifest. It's an OCI Artifact Manifest. What we've done is we've gone back and said, well, if we're going to have a new schema, then let's actually stop doing this goofy thing where we reach into the config object and decouple it. Let the config object be its own definition. In fact, 2 different artifacts can share the same config schema, because they, it could be application VND thingy2 -config. And if 2 want to share that same schema, that's fine. Because now we'll have a root property that says that this is a Notary V2 signature. This is a Helm chart. This is, whatever. We then basically just renamed layers to blobs. This has been a long-standing debate. They wish they did this back then. So we've just kind of done a cleanup here, because in container images, there is a layered format where it's an overlay, but in other artifact types, there's nothing ordinal about it. So it's just a blob. So we've just renamed it here. And then we have the addition for this Notary V2 signature can reference another image, another SBOM, something else that's in the registry. It's just a reference by its digestion descriptor. And if we look at the difference, it's really not that far, right? We've added the artifact type, we've renamed blobs, and we've added a manifest. So it's pretty straightforward. And now by this document, by declaring this, we can now do things like garbage collection and other management features in a registry without having to guess what's going on. So let me do some demos. And yes, please ask questions and we'll go through it. I want to get through a couple of these and then we'll spend whatever's time left for conversations, for questions. So this is an example of what we're doing with Notary V2. But this could be used for, IBM Simple Signing or other solutions or SBoMs or whatever. The premise that I'm showing here is how does a registry store additional artifact types? So we're going to show this in an experience. And I'm going to start with the Docker client here. Now, we didn't change the Docker client. What we did is we extended it with 2 plugins, a generate and NV2. And if I were to say Docker NV2 Notary, we would see those commands. Now, instead of typing those commands every time, I'm just going to create an alias to shortcut it. So now it'll look like the target experience we're shooting for. And rather than typing the fully qualified name of that image, I'm just going to use this environment variable for image for the Wabbit Networks NetMonitor V1 image. So I'll do so nothing up my sleeves, right? The only thing it's got is a local instance of the registry, which I've just hacked the host entry to be this registry name. And if I say Docker build, I'll build that image and its fully qualified name. So if I look at images again, we can see there's the NetMonitor image that I just built. I want to be able to sign this image. And one of our goals for Notary V2 is to support completely offline ephemeral clients locked up in a vault somewhere, no public access. So we need to be able to do everything without communicating directly to the registry. So if I say Docker sign, Docker Notary sign in this case, it's going to take that generate manifest extension, which we hope would eventually be in the Docker client or other builders, and it'll generate a manifest for that image. So it looks at all the digests. It basically tars the content up and then creates a digest and then creates a manifest for it. In fact, if I look under the covers, this is what we did inside of the NV2 extension that was in the Notary. So we were able to generate this manifest for that image. And if I wanted to cat the output of the signature, which for now we've just stored here, that's just the NV2 signature. And for the port of this session, it's not really that important. I have the signature, I have an image, I have those two things locally, and I want to push that content to the registry. Because I've turned on Notary in this experience, what I've said is I've told the Docker client, the plugin, to push not only the image, but push the signature as well and link them. So notice the push refers to the NetMonitor image. That's the digest for it. It pushed the image and it pushed the signature, linking them together. So I now not only have two pieces of content in the registry, I actually have them associated with each other. Now let's just clear things out a little bit. So what I want to do is simulate that I'm actually on another node. So I'm going to pretend I'm actually went from my build environment to some ephemeral client where I'm actually going to run this. Now, if I try to pull, I don't know what I'm trying to say, Docker pull image, what's going to happen is in this environment, it went and looked for that image, right? It's echo, try to go get that image. And because I've got the Notary capability turned on, it's looking, does the client have any signatures that are associated with that image? Now, right now, there's no signatures configured. So it says, well, okay, I found that image. There's one signature on it, and you don't have the public key. So I didn't get anything down, right? That's kind of what I want. I don't have any signatures. Now, if I go and configure the signatures, in fact, what I'm doing here is there's a key management portion that we're still working on in Notary. It's not really important. But let's say I've got a secure way to get the public keys to my machine, and now I have to configure my local environment to say I want to use that signature. So now, because I've configured it, Docker pull, it'll say it found a signature, and the key is I have a public key locally, so now I can actually pull that image. Now, the important part is how did that flow come together? That's the underlying thing that we're showing with the OCI Artifacts work. So what we said is we did not want to have to know about the specific digest of the signatures, because signatures should not have a tag. And we certainly don't want to guess what a digest is. What we want to be able to do is ask the registry for the NetMonitor image. Well, in this case, I show how to get the digest for the NetMonitor image. So once I get the digest for the NetMonitor image, not the signature, go to the repository for the NetMonitor, ask for a manifest by digest, and ask for the links. And the links will return this collection of linked artifacts. They happen to be signatures. And now the NV2 client can compare those and figure out if it's valid. But again, that's a Notary thing. The point is that the registry now knows how to store other artifact types that are linked to one. And with this new extension API, you'll be able to get those out. Okay, there is, try to be overview, went in deep, come up a little bit for air. We kind of bubble up a little bit, then we'll take some questions. So the idea is that registries can support these artifact types. They already were. We're just acknowledging what was already there and formalizing it. We don't want people that are working on new technologies for new artifact types that they want to use, like WASM was a great example. they shouldn't have to create another registry, get another storage solution just to store them. Let's just put WASMs in existing registries that we're already securing and running. Declare a new media type to identify your unique thing, register with IANA so you can claim ownership of that, and then you're good to go. If you're implementing one of these, we have some libraries like ORAS that you can use to extend that, and we're enhancing ORAS to support this new OCI Artifact Manifest, which is a work in progress. What you're seeing is the sausage being made. So that's where some of these conversations are happening with the artifacts. ORAS, we'll be doing some more work there and working to donate to one of the existing foundations. The Notary V2, and then some stuff on getting started. So I was kind of rushing because I did want to get to the questions.
Yeah, we have a couple for you. I read off.
Yeah, why don't you do it so I don't have to.
Yeah. So the first one's from Jeffrey saying, you mentioned teleport and confidential computing for the other artifact bits. And then I think you were saying, what is specific for teleport, session, and audit objects?
And what is specific about teleport?
Session and audit objects.
I'm not sure. So what? So there's Nidus. I think it was the example I was using. Is there's a group that is trying to do image expansion in a generic way that could run anywhere, and they were using this approach. They were hoping to use this approach to be able to store the expanded images in registries as well. The teleport stuff that we're doing is kind of deeply integrated into Azure. We're trying to take advantage of that, intimate knowledge of the network. So it's not really using this. It's a different implementation. But the idea is that I can take an image and add additional content to it. And that's what we can do with the artifact approach here.
Okay, great. I think that's what it's getting at. Jeffrey, please let us know if not. And then for confidential computing, he asked, is this stuff like INARX? I'm not sure how to pronounce that. INARX.
I'm not sure which one you're.
Yeah, let's retype it down here. The bottom one there on the chat, if you can see that.
Oh, sorry. Oh, yeah. So the confidential computing. So there's some work going on there, and I'm not sure exactly what I can talk about, what I shouldn't. So what I'm really just trying to get to the point is somebody asked me about other things that are stored in container formats and so forth. The confidential computing, they're trying to figure out how do they not break what we already use as registries. And so they were asking, how can I do some of this type of integration without, because one of the things we were reminding them is we don't want to change the digest or the tag of an existing artifact type. So that's how some of this stuff will come back in. Probably better for those folks to talk about exactly what they're doing, so I don't speak out of turn.
Okay, great.
We just put some stuff up there that kind of wants some more details.
And then Valentin and Nisha kind of shared a question, so I'm going to go with Valentin's. And his was, I would love to have these references in ordinary, i.e. non-artifact OCI images. Do you know if there are any plans to extend the OCI spec to cover references?
Yeah, so this is, so as I mentioned, I'm on the OCI TOB and Artifact Manifest and so forth, and this is the active conversation we're having. To make reference artifacts works, you need two things. You need a new manifest that can declare the reference, because we want that to be a self-contained document so we can do garbage collection and track it when it gets submitted to the registry. And then you need this API that says, well, what was linked to the thing that I'm trying to target? What is linked to the net monitor image? We'd love to see those added to distribution spec. Some of these things kind of have to work their way up. So right now we're going to submit them as an extension in the OCI Artifacts repo and hope that the notary work is compelling enough that people would implement them. And if so, then we can promote them hopefully to the distribution spec, because we agree that this is something that we'd like to just see in distribution. But I don't solely own that. There's a bunch of other people that have to be convinced of that as well. So we hope that's what will be elevated. If you look at every cloud vendor and pretty much every registry that I know of supports the OCI Artifacts approach today, where you can expand the config media type. So we're hoping that this is it's not as easy as opening up the config media type validation that we did before, because when you start adding reference types, when you delete the net monitor image, you actually want the signatures to go with it. So there's more work in garbage collection that has to be done. So we do know that this will be more work for registry operators to implement. We're hoping the signing solutions that people are doing with Notary V2 is a compelling business reason, will justify the resources to do it. And like I said, hopefully it'll just get, whether it's, I think for the average user, it shouldn't matter whether it's in the artifact spec or in the distribution spec. It's really a matter of whether registries support the experience.
Okay, and then Lee, and I'm probably butchering his name, Leigh Capilli, asked, is the new OCI artifact with the artifact type field meant to be used now, or is that a future work thing?
It's future. So what you're seeing, I think I put some links to it here, is, this OCI Artifact Manifest is a work in progress. I've got the pull listed here. It's not even a spec right now. It's still kind of the preview to these slides of describing it. We are working on changes that we will submit to CNCF distribution to support it, and we'll work on a spec. If I wasn't prepping for this talk this week, that was one of the things I was going to work on. So I'm hoping to get that turned into a spec, and we'll see shortly. My need, because we need to get this out for business reasons, is to get the CNCF distribution, have at least some basic implementation of this, so that people can run that locally, like I'm doing here, and test the experience. And as we turn it into a spec and we get more confident around how we would implement this at massive scale that we as the many cloud vendors implement, then we'll start rolling this out in ACR and hopefully ECR. I know ECR is committed, and hopefully GCR would as well, and IBM and so forth. So I'm hopeful that by this summer, we'll have this experience working in some amount of a preview, and we'll, based on the feedback, we'll harden it up and hopefully be able to run this in production by the end of the year.
Okay. And you also had a kind of a related question too, is what's the meaning of config media type in an object with an artifact type? Is that sort of just soft deprecated?
So if it ain't broke, don't fix it. So the Helm charts today are working fine with the config media type, and all the other ones, or in fact, all of those, because this thing that we're talking about today doesn't yet exist. It's a work in progress. It'll be up to them whether they want to migrate. So there's no deprecation. I imagine things will be used like this for a while, and people, whether it's Helm or others that will move to the new OCI Artifact Manifest, it's up to them. And again, hopefully that'll really just be for the implementers. This is one of those technologies that like a dozen people on the planet will have to do some of the core work, and then everybody else just gets to benefit from it. So if you are one of these artifact authors, let's talk. And are we covering what you need, and what do you need to elevate this? But hopefully the rest of the humans on the planet will just get to benefit from the work.
Okay, great. And I must apologize, Steve. I think at the very beginning of the talk, I identified you as working for IBM when you instead work for Microsoft, not IBM. So I just want to make that clear.
One of the blue companies, yeah.
Yes, all blue, you get them all mixed up. So, and I would just like to thank you for coming today and being at our conference and doing such a great job. It was a wonderful talk. We've got a lot of great feedback from the folks. I think we are done with questions. So with that, I think we'll wrap this one up.
You can find me on there. So thank you all for attending. Thanks for the great questions.
Right.